Hello, MOS 4472 team. In this video, I'm going to take you through chapter 7, which is the data analytics chapter. So let's get started. I'm going to share my screen with you and put it into full screen mode. Change my settings. Okay, let's get started. So chapter 7 is called Data Analytics. And let's get started. Our learning objectives are to identify career opportunities for accounting professionals working with data, describe data analytics techniques that can explore data, evaluate data analytics techniques that explain changes over time, and then summarize advanced data analytics techniques that transform data into insight. So let's start with objective 1 to identify some opportunities. There's different types of analysts, and companies collect data, need people who can transform it into useful information, especially since we have a lot of big data being stored. So it's important to take that data and actually transfer it into insights and information that can be used in decision making. And there are many career paths that involve working with data. Some require technical training, such as data scientists. Others require statistics or computer science, and others rely on skills learned on the job as accounting professionals. So as accounting professionals, we are great for the financial analyst roles and the business analyst roles that work with structured data and look at making insights. Okay, so data analytics related job titles and descriptions. We have data engineers who build the technical infrastructure and architecture for gathering, growing, and storing raw data. And we also have data analysts, data scientists, and statisticians that depend on the work of data engineers to have access to data. And their expert understanding is data modeling, hardware, networking, and databases. So these are computer science type majors. Then we have data scientists, and they work with large volumes of data. They design and program algorithms to collect and analyze data and perform predictive analytics. They possess technical skills such as understanding of higher level math, and you need some coding proficiency. And their expertise is data modeling, statistics, programming, and coding. Then we have data statisticians who perform a methodology for drawing conclusions from data. Their role is math-oriented and focuses on collection and interpretation of quantitative data using defined scientific methods, and their expertise is data and statistics. In my research, I've learned quite a bit of statistics because I need to use statistics to infer insights from my studies, to find relationships, but you can also do these types of analysis in the workplace. Then there's data analysts who collect, manipulate, and analyze data across a business. They understand the business processes and technical aspects of the organization. This is a less scientifically focused role than a data scientist or a statistician, but it's coding oriented in comparison to a business analyst. So as I mentioned, we as accountants are more suitable for data analyst roles. And this role requires both technical and interpersonal skills because you are working with different business functions and trying to get the data and information for them that they need. Their expertise is data transformation, programming and coding, and business processes. The last category is the one that we as accountants are more suitable for, and that's the business analyst or the business intelligence analyst. And here you work with data to find trends and leverage insights. You need to process a deep understanding of business processes, and you can evaluate them and analyze key metrics and provide strategic recommendations. You must assess requirements from a business perspective and understand data visualization. Communication is very important. People in this role must effectively present information and actionable insights to business leaders. So business analysts work really closely with business management, focusing on strategy and gaining insights into how the business is doing. The expertise is data transformation. You need to understand business processes and visualization techniques. Types of analytics. There are 4 different types of analytics that we can perform: descriptive, diagnostic, predictive, and prescriptive. The first 2 categories, descriptive and diagnostic, look at the past and use historical data to learn more about what occurred and why it occurred. So descriptive analysis describes what has occurred, whereas diagnostic analysis tries to infer why things occurred. So for example, a descriptive type of analysis might be you look at sales and sales are down in Q4 versus like Q1, for example. And then diagnostic analysis will try to say why sales fell down. And then you can look at product level information, geographical information. You might see, oh, you know what? We are an ice cream business and we had it was a lot colder in Q4 than Q1. So not as many people were purchasing ice cream outside. So that's the why. So you need to look at additional information to find out the why. The what is usually contained within the company data. These 2 types of analysis are less complex than predictive and prescriptive analytics, which analyze historical data and also predict future events, providing recommendations on what the business should do. So here are the categories of data. Descriptive and diagnostic look at the past and they answer the questions of what has happened and why it has happened, while predictive and prescriptive look more at future data. And with predictive, you're looking at what is likely to happen. Predictive analysis is done by business and accountants all the time, especially management accountants when you are planning for the future year, trying to figure out your production plan, your sales plan, your inventory plans, whereas prescriptive looks at how we should act. Okay, so descriptive analytics tell us what has happened. They look at historical data and condense it into smaller, more meaningful bits of information. And this is the most common form of analysis. The key characteristics of this type of analysis is that it's easy to access, easy to visualize, and it's based on historical data. The key questions answered is what is happening, how many times did it happen, when did it happen? And as I mentioned, with descriptive analysis, you would have most of the information in the company's database. Then diagnostic analysis provides insights into why something happened, drills down to a granular level, often looks at data in a variety of ways to identify trends or investigate causes. The key characteristics of diagnostic analytics including it's used to troubleshoot and investigate issues. It drills down to the root cause and it's based on historical data. And it answers questions as to why did it happen? Where did this come from? How can we avoid this problem in the future? And then we have predictive analytics, and these use statistical modeling and algorithms to predict what is likely to happen. So you're looking at the future provides powerful tools that assist in decision-making and inform future actions, and it requires assumptions and identifies possible outcomes based on these assumptions. Predictive analytics uses statistical modeling and predictive algorithms. It yields better results for larger data sets because then you have the machine learning going on. And it's based on historical and live data. And it answers questions such as what is likely to happen? What is the logical outcome? Then we have prescriptive analytics, which identifies what we should do. It requires advanced programming, consists of advanced cutting-edge technology and design, uses a decision-making protocol and historical data to train a program on what to do in a real-time situation. Its key characteristic is that it requires advanced technology and algorithm. So you're looking at artificial intelligence, machine learning, uses the 3 previous analytic types for insights. It's based on historical and external data. It's very costly to implement, and it answers questions as to how should we act? How should we make this decision? Machine learning. So I've mentioned machine learning a few times within this video. So let's define machine learning. Machine learning uses algorithms and statistical models to train an AI system through patterns and trends in data sets. Machine learning programs systems to perform tasks without explicit instruction and is a popular application of artificial intelligence or AI in data analytics. There's 2 different types of machine learning. One is supervised learning, which involves humans, and the other one is unsupervised learning, which doesn't have any interference of humans. So let's look at a further description. With supervised learning, we use labeled data sets to train the algorithm to classify data or predict outcomes from a data set. Before it can begin, human intervention is necessary to establish the labels within the data set. So examples of supervised learning is classification, so putting different products into different categories based on different rules you set for the computer, or regression analysis. And then unsupervised learning uses algorithms to analyze unlabeled data sets for hidden patterns. It does not require human intervention, so the machine just kind of learns on its own. And examples of unsupervised learning include clustering, association, and dimensionality reduction. Then we have reinforced learning, and reinforced learning, think of kind of like children. You praise them if they do great, and you punish them if they make a mistake. So it focuses on decision making by rewarding desired behaviors and or punishing undesired behavior. Decisions are made sequentially by the artificial intelligence, and each decision is rewarded or punished to train the AI system. This hybrid approach may require human intervention, but not necessarily. And examples of this are task learning, skill acquisition, robot navigation, real-time decisions, and Monte Carlo simulation. Supervised and unsupervised learning. So the primary difference between supervised and unsupervised learning is the use of human invitation to create labeled data sets. So labeled data contains predefined tags or descriptors that a machine learning algorithm uses to understand the data set or learn from it. So we as humans are basically telling the machine or a algorithm what to look for and how to classify it. Labeling data is a human act of intervention, which occurs only when using supervised machine learning analytics. The next learning objective is to describe data analytics techniques that explore data. Okay, Exploratory data analytics techniques reveal the key characteristics of a data set. There's categorical values, which are usually written values. There's quantitative values, which is numbers. Think about sales information. And then there's patterns or trends that you can infer from the data. So data composition refers to the first two key factors. Categorical values are the descriptive components within a data set and are qualitative in nature. Then we have quantitative values are the numeric data points that can be summed, counted, or otherwise analyzed using mathematical operations. And then the third key factor that data exploration reveal is patterns of recurring or similar values, either categorical or quantitative. Patterns that occur over time are called trends. And as data analysts, we are looking at patterns because those patterns allow us to answer questions and gain understanding. So for example, a pattern or association you may find that the sale of umbrellas go up when it's raining. So if you look at the rain forecast and sales patterns of umbrellas, those two factors should be intercorrelated, and you should have that strong correlation, and you should be able to see that pattern over time. Anomaly detection. So anomaly detection, also known as outlier analysis, reveals observations or events that are outside the data set's normal behavior. Anomaly detection is an important data analytic objective that can be the purpose of many data analytics techniques. Anomaly detection is applicable to every part of the business, including banking, cybersecurity, and marketing. So even in my research, I look for anomalies because they reveal something about the information. So for example, from my research perspective, I have to identify outliers because they are outside of the normal distribution and they might skew my results and aren't within the observable pattern. But for example, from banking, it's important for banking software to look at anomaly detection because it's able to identify fraud. So think about when you are traveling and you take your credit card and you don't inform the bank. Sometimes your credit card gets frozen because the bank can pinpoint, oh, you know, for example, me, Joanna lives in Ontario. Her credit card is now being used in California. What's going on? She doesn't live in California. This isn't something she usually does. And then the bank would freeze my credit card to prevent further losses or fraud. In terms of cybersecurity, if we're logging into a system, for example, I have to log into Western and I usually do it from my home. So if all of a sudden I was logging into the Western system from Australia, that might raise a red flag. I have security features with Western. I'm not sure if students do, but we as faculty have this dual app where I have to verify, yes, it's me. It comes up on my phone every time I try to log in. But from a cybersecurity, it's a lot easier to see who's trying to access information by tracing an IP code. From a marketing perspective, you might identify bots or something if you're receiving a lot of traffic to a website and there's no reasoning. So for example, if you don't have a sale or anything like that. Data summarization occurs when you're exploring a new data set and understanding its composition commonly involves the data analytics technique called data summarization, which involves simplifying the data to quickly identify the composition of categorical and quantitative values. So the first thing you're going to do if you ever get a data set is look at it and go through a cleaning process. So when we go through our cleaning process, we try to identify if there's any outliers in the data, if there's any replications in the data. So are there occurrences that occur more than once? If you're looking at a historic data set and you're pulling certain years, you want to make sure that you only have the years you looked at, and you do this through a quick data summarization. You also need to look at all the columns and categories of the data and the meanings of them. So what are the titles of my data set? What are they referring to? So here is an example of data summarization. We have Julie's cookies, which we see throughout the textbook. And this data set contains one categorical value and one quantitative value. So we have various product names and the prices of the product. So we can understand this data set. So for example, if we get sales data, we know that it will show the products and the price. You'll likely have a quantity and a total sales. And then a customer order is summarized by the product name to calculate the quantity and the cost of each product ordered, as well as a grand total. So you have the name, the number of times the product was ordered, and then you multiply that by the price to get an amount. So for example, here we see that 3 milks were ordered. If we look at our previous slide, milk is 225, so 225 times 3 is 675. Clustering or cluster analysis is an analytics technique that categorizes data points into groups based on their similarities. The groups called clusters are determined by the distance between individual items, which indicates how closely related the data points are. Clustering is an unsupervised machine learning technique in which the data input contains unlabeled data. In cluster analysis, the machine learning algorithm finds similarities between data points to group them together without human intervention. So here we see cluster analysis. So you have an x-axis, you have a y-axis, you put the data point, you plot the data point, and then they're clustered together based on how close they are. So here you have 3 different clusters. So here's an example of cluster analysis. You have unlabeled data. So here we have some drinks, we have some cookies, we have some brownies, and it looks like some chocolates. And then with unsupervised learning, the logarithm identifies similarities. So they identify that these are round and chocolate, these are round and not chocolate, these are square and not chocolate, these are square and chocolate. And then there's the bottle of Coke that it doesn't like because it doesn't have any similarities. So if we were using supervised machine learning, we can identify what are drinks, what are cookies, and what is something else. But unsupervised machine learning, the computer or logarithm tries to find similarities itself without any labels. Then we have classification analysis, is the categorization of data into groups based on similarities found in a data label that was previously defined. Classification analysis and clustering differ in the types of machine learning they used. Clustering uses unsupervised machine learning to analyze unlabeled data inputs, whereas classification uses supervised machine learning to analyze labeled data input. So in this term, we're using classification. So we as humans would create a category and we would go through the list and say what each product is. So in this case, it looks like they identified products as cookies, brownies, truffles, or beverages. And then the information goes into the system, and with supervised machine learning, the computer sorts it between cookie and non-cookie items. And then when a new product is introduced, it remembers the categorizations and what things are, and it's able to identify a new cookie as a cookie. So our third learning objective is to evaluate data analytics techniques that explain changes over time. And these are time series analysis that capture data that occurs in chronological order across a period of time. A time trend is a consistent movement in the time series data that does not repeat. Seasonality is a consistent movement in the time series of data that repeats on a regular basis. So for example, with clothing, we see parkas being purchased in the fall for the winter, and we see shorts being purchased in the spring for the summer. Noise are then additional movements in the time series data that cannot be explained as a trend or seasonality. So these are items that occur that we have no explanations for. So here is an example of a time series analysis. And what we see here is sales for pumpkin spice cookies. And it looks like they are being purchased from September to November, fall time, which makes sense because that's when pumpkin spice is popular. Then we have linear regression. Linear regression is a statistical technique we use to estimate the relationships between a dependent variable and one or more independent variables. A dependent variable, this is the value to be understood. It is often called the outcome. An independent variable, this is the factor that may be influencing the dependent variables. So in a counting studies that I do in my research, I look at how the independent variables influence the dependent variables. So what is the relationship between variables? So one study I'm looking at right now that I'm working on and submitting to a conference looks at the effects of events. So whether they're foreseeable, so you as a manager know they're about to happen, or unforeseeable, so they're unexpected, and the attribution the manager makes. So either you say, you know, this event is my fault, I feel like the perpetrator of this event, or alternatively, this event is not my fault, I feel the victim, and I manipulated both variables, and the dependent variable that I looked at was, in this case, whether or not the supervisor adjusted the employee's bonus for that event. And what I found was a direct relationship between event and adjustment. So managers are more likely to adjust your bonus if the event is unforeseeable than foreseeable. And they're also going to give you a higher bonus adjustment if you make an external attribution. So you blame the environment versus blame yourself. Linear regression is either simple or multiple. Simple regression, one dependent variable and one independent variable. Multiple regression, one dependent variable and multiple independent variables. So the example I told you about was a multiple regression. The simple regression would be to look at the effect of the event type, foreseeable or unforeseeable, on the adjustment of it. Simple regression is always identified by the line, by this equation, y equals a plus bx. So A is your y-intercept, so where the line, it's the y-axis. X is the quantity of the independent variable, and B is the slope of the line. And regressions are always plotted as a line, and what you will see actually is a bunch of dots, blah, 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 and then you do the line of best fit or the regression line based on where all the observations are. Forecasting is the process of estimating future events based on the combination of past and present time series data. This predictive analytic method is a staple in accounting data analytics. Several statistical methods, including linear regression, can create forecasts. It is not limited to regression, and other statistical models can be used, for example, Monte Carlo analysis. So in this example, we have forecasting for year 3 and year 4. And what you see with this forecast, you have your lower confidence bound, your upper confidence bound. So you set your confidence bound, usually they're 95%. And then most of the observations will fall here. And then the actual forecast line is going to be in the middle of your lower confidence limit and your higher confidence limit. The lower confidence bound or limit and the upper confidence bound are part of the confidence interval, which is an estimate derived from observed data that shows a range of possible values. Businesses like to use a 95% confidence interval when they are performing forecasting. The upper and lower bounds are important elements of forecasting, as the forecast line is just an estimated mean. Then we're going to talk about simulation, and specifically Monte Carlo simulation. A simulation uses complex calculations to predict the outcomes and probabilities associated with a decision that influences a data set. It can study the causes and effects of various actions. Simulations are adjusted to test different actions, and the predictions are reviewed each time the simulation is run to evaluate how the actions affect the model. A popular simulation is the Monte Carlo simulation, which predicts the probability of different outcomes in the presence of many random variables. So with Monte Carlo simulation, you have the simulation run like hundreds of times, thousands of times, and then you get the most likely outcome. Some of the stats I do run on a simulation. So for example, I do structural equation modeling, which tries to determine relationship between various factors, and it does run a simulation analysis trying to find the most likely relationship. And here's an example of Monte Carlo simulation. It's using R, which is a statistical software. The benefits of R is that it's free and there is a huge community, so you can use other people's codes and just learn to use R by reading online materials, and it's constantly being updated. And as I said, the main benefit is that it's free. And what you hear with this, the simulation, each line and color is a different possible scenario. So it just looks at the data in so many ways and so quickly, and you can see all the possible outcomes, and then it creates a most likely outcome. Monte Carlo is an important simulation in the business world and can be used in many contexts, including investment banking for stock price. You can use it for personal finance to look at your portfolio return, corporate risk management, product management, and cost accounting. Okay, the next thing we're going to look at is summarizing advanced data analytic techniques that transform data into insight. So one of the things that can be done is process mining, and this is time series data is a specific type of data captured over a period that is useful for regression, forecasting, and even simulation. A subtype of time series data that is specifically related to events, and a unique data analytics technique that is used with it. So we have event log data is data about activities in a system and includes the timestamp of when the activities occur. So for example, to manage employees, you can look at when they enter various transactions. So if you have a customer service business and you're serving clients, you have your customer service rep log into the system and do various entries. So you can see the time they take it with the customer. You can see the transaction start time, transaction end time, and then you can see their next transaction start time, transaction end time. So with this type of information, you can look at how many lulls occur, how productive the employee is, whether they take breaks between clients, etc. And then process mining uses event log data to show what individual systems and machines are doing in visual formats. Any business process that captures system data with timestamps, such as accounts payable, supply chain processes, and even journal entries can be analyzed using process mining. In addition to identifying segregation of duty violations, process mining can detect inefficiencies in business processes and circumvention of internal controls. The outputs of process mining analytic is an easy to understand map that draws attention to unexpected events. So here is a process. So you have the start of the process. In this case, it's a new purchase requisition. It requires approval. Then you have to verify the vendor. You create a new purchase order. You have the order approval and then order placed with the vendor. And with process mining, you see that there are 4 new purchase requisitions in the data set. 3 requisitions went through approval in the system before the vendor review. 1 purchase requisition was not approved in the system before vendor review. So with this process mining, you can find examples of fraud in this case because the process wasn't followed. So this transaction looks suspicious. So you are better able to investigate it. So process mining allows you to find irregularities, and then you can, by pinpointing the irregularities, you are able to spend time actually investigating them and finding fraud and other things. Candidate for process mining, any part of the business that captures event data is a candidate for process mining, including investment firms, journal entries, and information technology. Then another type of analysis is network analysis. Network analysis is an analytics technique that visualizes relationships among participants in a data set to learn about the social structure those relationships create. It can be used to study relations among people who are displayed as nodes in a network analysis. The link between the nodes are the relationships or interactions that connect the participants. Network analysis was done a lot during COVID to track people and try to do contact tracing. So you looked at various people and interactions and tried to pinpoint where the disease was spreading. So here is an example of the network analysis. In this case, this is different shopping patterns of different people. You have this person, Adam, who seems to have spent a lot of money in the Apple store versus his Amazon order. And then you have various other people that purchase things in the Apple store and then other stores, and they're connected other individuals. So in this way, you can identify what's occurring. It looks like maybe Adam was a victim of fraud. So by looking at his unusual transaction, you can look at all the other people that purchase things at Apple and try to determine whether this gentleman and this lady were also victims. So geospatial analytics is a technique that gathers, transforms, and visualizes geographic data and imagery, including satellite, photograph, global positioning system, or GPS coordinates, and more. It has grown in popularity as location data has become increasingly available. A lot of apps that you have from various stores track you on your phone, so they're able to know where you are. And this way, organizations can use this information to send their customers special coupons or promotions. So many organizations are using this information, and because most of us have a phone and a million apps are able to track us. So here's an example of a GPS data visualization. This is GPS data from mobile app users is presented, so you can see where all your customers, for example, are located. So if I'm a store in New York City, I can see that all the people that shop at my store are located around the New York area. Then we have natural language processing, which is textual analysis. And this is a category of data analytics techniques used to interpret objects that include words. It can interpret text transcriptions of conversations, emails, process narratives, and flowcharts. And it's used to analyze business processing. Natural language processing is a form of textual analysis that gathers, processes, interprets meanings from human language. NLP uses machine learning algorithms to learn the meanings of words and improve interpretation based on what the algorithm learns. NLP applications, there's both supervised and unsupervised machine learning algorithm can perform this natural language analysis. NLP has a variety of data analytics applications. It can create AI that answers questions like chatbots, classify documents based on content, such as reviewing legal documentation, and analyze the sentiment of text. This software has come a long way, but it's not perfect. So I use an app called Our Family Wizard because I'm divorced and I share custody of my child with my ex. And this application has a AI kind of software trying to look at sentiments of text so that when you're writing a message to your co-parent, it comes across as nice. The problem is certain words are detected that shouldn't be. So for example, if my son is sick, I will write, oh, he's not feeling well, he has a headache and a fever, and the he's not feeling well is seen as like aggressive and problem. So there are nuances that machine learning cannot process. The nice thing about it is I know many researchers that do qualitative analysis. So qualitative analysis requires you to interview individuals and ask them questions. And then you record them, whether or not you're kind of typing out what people are saying, or you are recording them like the audio recordings. And takes a lot of time traditionally to process and analyze this kind of information. Because when you have a free conversation, you're collecting a lot of data and it's hard to find similarities with the data. You have to actually code it and have people go through it. And these processes can take months and months and months. But with machine learning, there are software that you can put this information in and it tries to see patterns. It's not perfect, so you still need the human intervention to read it, review it, see if it makes sense, but it does help. Then there's sentiment analysis, also known as opinion mining, uses NLP to interpret and classify the emotions underneath language in textual format. It uses machine learning algorithm, sentimental analysis can rate emotions underlying text communication. Connect a sentiment to a cause by determining what aspect of the text is causing the sentiment. Discover patterns in big data based on emotional context. Detect specific emotions such as happiness, anger, sadness, and disappointment, and sort big data based on emotional context. And here we have an example of sentiment analysis. They're looking at positive, neutral, and negative experiences, and it's analyzing the word. So fantastic is rated as positive, okay is neutral, and useless is negative. Sentiment analysis applications can provide insights in businesses for social media posts about the business. Board meeting minutes can be analyzed. Employee satisfaction surveys, customer satisfaction surveys, auditing documents, and journal entry analysis. So that is it. I hope you found this presentation helpful. Looking forward to seeing you in class. Have a lovely day. Take care.